Okay, we really need to completely reframe how you think about rest. Seriously, stop viewing sleep as this passive state of dormancy. Just a time when you shut down for the night. That's entirely wrong. As we'll see in this explainer, the science reveals that sleep is actually an incredibly aggressive, bidirectionally regulated biological action. It's a highly coordinated neurological restructuring process, and it's absolutely crucial for your survival, your emotional resilience, and your long-term cognitive preservation. We are going to explore the hidden mechanisms that govern this whole process, from your autonomic nervous system all the way down to the exact temperature gradients required to unlock deep healing. Let's dive in.
So 65%, think about that number for a second. This represents the exact increase in endogenous dopamine release in the striatum triggered by a practice called yoga nidra, or non-sleep deep rest. Now, we aren't just talking about basic sleep hygiene here, or, feeling a little more refreshed in the morning. We're dealing with profound, measurable neurophysiological restructuring. The fact that a guided relaxation practice can cause a 65% surge in dopamine, that proves we literally have manual levers we can pull to physically alter our brain chemistry and nervous system function. It's a real game changer. But to truly optimize this system, we have to reason from first principles. Your central nervous system and your autonomic nervous system are in this continuous, lifelong dialogue. If you're someone who struggles with insomnia, frequent awakenings, or just constant exhaustion, you have to ask yourself, what if your inability to sleep isn't a sleep problem at all? What if it's a highly adopted survival response? See, when you are pathologically locked in a high-stress survival state because of modern demands, your biology perceives your environment as dangerous. It thinks you're being hunted. So making those restorative physiological transitions into deep sleep becomes completely impossible.
It really comes down to a biological tug of war. On one side, we have the sympathetic nervous system, your classic fight or flight mode. A locked sympathetic state literally blocks slow-wave sleep. It keeps your heart rate elevated, your brain highly vigilant, just waiting for a threat. On the other side is the parasympathetic nervous system, which is driven by vagal dominance. It is only when this rest and digest system takes over that your body can stabilize its heart rate, drop your blood pressure, and actually initiate the deep metabolic recovery that repairs your cells and consolidates your memories. And if that sympathetic state stays locked on, it creates a nasty, vicious feedback loop. When you experience chronic stress, your HPA axis, the hypothalamic pituitary adrenal system, becomes hyperactivated. This leads to chronic cortisol elevation. But unfortunately, it doesn't stop there. This hormonal flood pushes pro-inflammatory cytokines, specifically things like interleukin-1 beta and TNF-alpha, right into your system. This neuroinflammation creates what we call glutamatergic excitotoxicity. Essentially, your brain's engine is revving so incredibly high that it becomes toxic, which violently fragments your sleep and then just restarts the whole stress loop the next day. Well, what happens when this whole system actually starts to break down? Well, the data gets completely counterintuitive here. You'd naturally assume that pulling an all-nighter would skyrocket your stress hormones, right? But surprisingly, clinical studies show that acute 24-hour total sleep loss actually lowers your morning cortisol. Now, while that might sound like a relief, it's actually a massive alarm bell. This decrease indicates a dangerous, transient exhaustion of your entire HPA axis. Your body's circadian pacemaker is losing its ability to mount a normal morning stress response. So you aren't calming down. Actually, scratch that. Your endocrine system is simply running out of gas. Okay, so to escape this stress loop, your body must physically transition into a sleep state, and it does this through a highly specific thermal mechanism. It initiates a literal heat dump driven by the distal proximal gradient, or DPG. As evening melatonin rises, your body triggers pre-sleep vasodilation. It actively pushes blood and heat away from your core and out to your hands and feet. This aggressive cooling of your core temperature is a strict, non-negotiable biological requirement for sleep onset. Simply put, if your core doesn't cool, you don't sleep. Now, you might think that heating yourself up right before bed is a terrible idea if the whole goal is to cool down. But clinical data reveals a brilliant biological hack. A study on older adults with sleep disturbances found that taking a 40-minute foot bath at exactly 41 degrees Celsius paradoxically cools your core. By aggressively heating your extremities, you force massive vasodilation in the feet, which dramatically widens that distal proximal gradient. Your body rapidly dumps its core heat, significantly decreasing wakefulness and drastically shortening the time it takes to fall asleep. So once that core temperature drops and you successfully enter slow-wave sleep, you unlock one of the most critical health span mechanisms ever discovered, the glymphatic system. Discovered just over a decade ago, this is a glia-dependent perivascular transport pathway. In plain English, it is a literal fluid dynamics pressure washing system for your brain.
During the day, metabolic waste naturally builds up in your brain tissue. But at night, this magnificent system kicks in to aggressively flush that neurotoxic waste right out. Let's look under the hood at exactly how this nightly pressure wash works. Step 1. Your brain's noradrenergic tone, which is driven by the stress chemical norepinephrine, has to drop. Step 2. This drop slows down your vascular motion. Step 3. Specific water channels in your brain's glial cells, called AQP4 astrocyte channels, physically expand. This expansion actually increases the space between your brain cells, allowing cerebrospinal fluid to rush in and flush out Alzheimer's-linked proteins like amyloid beta and tau. If you don't get deep non-REM sleep, this pressure wash never happens. It's that simple.
While deep non-REM sleep beautifully washes the physical brain of toxic proteins, it leaves us with another profound mystery. Because, the brain doesn't just accumulate physical waste, it accumulates emotional baggage. We have to ask, how does the brain cleanse itself of emotional trauma, profound stress, and fearful memories that we pick up during the waking day? Well, there is a stark contrast in our sleep architecture. Unlike the deep, stable parasympathetic rest of non-REM sleep, where your heart rate is incredibly calm, rapid eye movement, or REM sleep, is chaotic. It's a state of intense sympathetic spikes, high cardiovascular instability, and an incredibly active amygdala, which is the brain's emotional center. Honestly, to your autonomic nervous system, REM sleep looks a whole lot like being awake and highly stressed. But here is the absolute genius of your biology. During REM, your brain acts as its own overnight therapist. It actively replays the emotional memories and traumas of the day within the amygdala. But it does this while the stress chemical norepinephrine is completely shut off in the forebrain. You are safely processing fearful memories in a neurochemically calm environment. It systematically strips the sharp, painful emotional charge right away from the memory, so you can actually cope with it the next day. It's incredible. But here is a terrifying reality. This delicate, incredibly complex neurological restructuring can be completely shattered by something totally invisible in your environment: carbon dioxide. If the CO2 concentration in your bedroom exceeds a specific threshold of 1,000 parts per million, which, by the way, happens very easily if you just sleep with your bedroom door and windows closed, your sleep architecture is quietly, fundamentally destroyed, even if you feel like you slept for a full 8 hours. When CO2 rises above that threshold, it acts as a respiratory stimulant. Chemoreceptors in your brainstem detect the toxic air, and your brain literally panics. It increases your respiratory drive to expel the gas. To do this, your brain triggers constant micro-arousals, these tiny awakenings you don't even remember. But these arousals pull you completely out of that deep, restorative lymphatic clearance just to keep you breathing. So, yeah, you survive the night, but your brain doesn't get washed. Thankfully, you don't have to be a victim to a dysregulated environment or nervous system. We have tools. You can manually override your autonomic nervous system using precise cardiorespiratory modulations. For example, the 4-7-8 method leverages breath holds to build CO2 tolerance and lowers sympathetic drive. Then there's resonance frequency breathing, which optimizes your baroreflex to maximize heart rate variability. And cyclic sighing, which is a double inhale followed by a long exhale, has been clinically shown to rapidly reduce state anxiety by offloading CO2 and inflating the alveoli in your lungs. However, the data shows you must choose the right tool for the specific physiological state you are currently in. Take post-exercise recovery, for example. Resonance breathing at precisely 6 breaths per minute seamlessly lowers the heart rate down to around 154 beats per minute, beautifully supporting bagel tone. But box breathing, which involves breath holds, keeps the recovery heart rate elevated at 164 beats per minute. Doing breath holds during a high-stress recovery period actually imposed unnecessary cardiovascular strain. Specificity really matters here. Now, if active breathwork feels just too demanding for your current state of exhaustion, sensory withdrawal practices like yoga nidra offer an incredible alternative. Without any physical exertion on your part, this practice systematically shifts your brainwaves from alert beta rhythms down to slow, relaxing alpha and theta rhythms. Physiologically, it induces an average respiration drop of 1.4 breaths per minute, significantly reduces your blood pressure, and aggressively lowers systemic cortisol, restoring that healthy daytime-nighttime slope we talked about earlier. Ultimately, understanding and regulating your nervous system isn't just some biohacking trick to feel a little less tired during the workday. It is the absolute fundamental biological foundation for clearing neurotoxic waste, processing emotional trauma, maintaining cognitive preservation, and unlocking a much longer health span. You have the tools now, from managing your thermal gradients and bedroom air quality to directly modulating your breath.
So the profound question remains, are you merely surviving your nights, or are you actively engineering your longevity?